Students, we have another new topic is according to arrangement of atom in unit cell. एटम के अरेंजमेंट के बेस में यूनिट सेल को हमने तीन तरीके से क्या है इसको डिस्क्राइब किया हुआ है. we see as a column wise unit cell first column, second है atom arrangement और rank of the unit cell. So all the unit cell we have discussed properly. Four types of, that is called simple unit cell, face centered unit cell, body centered unit cell, end centered unit cell. Simple unit cell, total arrangement of atom, how many are there? Only in simple unit cell 8 corners are there. So you will see there 8 into 1 by 8 is equal to 1, rank will be 1. And in face centered unit cell, so face centered unit cell, in each corner 8 points are arranged there. 8 into 1 by 8 is equal to 1. Faces are 6. So in each cube, a box like a structure, there are 6 faces. So that's why each faces 2 half will be there. So 6 into 1 by 2 is equal to 3. So 3 plus 1 is equal to 4. It is called rank of the FCC is called 4. And body centered, so corner is 8 into 1 by 8 is equal to 1. And body centered 1 is 1. In body centered, apart from the each corner, we have already discussed there. Say inside of the body centered, one another point also situated there. So in this way 1 is equal to 1 plus 1 is equal to 2. So rank of the unit cell of the body centered is equal to 2. एंड सेंटर्ड में हम देखेंगे जो एंड सेंटर्ड यूनिट सेल है, ईच कॉर्नर 8 पॉइंट्स आर अरेंज देयर. सो 8 into 1 by 8 is equal to 1. और एंड सेंटर मीन्स टू अपोजिट फेसेस, टू फेसेस 1 by 2 is equal to 1. So 1 plus 1 is equal to 2. In this way rank of the unit cell is 2. In this way a question may be asked in objective types, what are the rank of the unit cell of simple, what are the rank of the unit cell of face centered FCC, what are the rank of the unit cell of BCC, what are the rank of the unit cell of ECC. So we can calculate this. Now after this we discuss there, types of unit cell are two types of unit cell. First, it is known as three types: one dimensional, second is called two dimensional, and third one is called three dimensional unit cell. So first we will discuss the one dimensional unit cell. If we see about the one dimensional, any points when situated in the sequence order, it is a one liner we can say. So this is called the one dimensional. Only one parameter is required there to design the one dimensional. So it is a not of large form we can say. In second form we discuss there. In two dimensional unit cell, 2D is known as. So these are the points which are situated there, sequence order same as. So we can say this is the one side and this is the another side. So only there are two direction are there. So either you can take this as in the form of this or in the form of this. In each direction you will take there two direction. So this is called the two dimensional. And sides are there. So this is called the angle of the side or angle of the two dimensional side, or this is called the A side, this is called the B side. Now Overall, how many there are, we require the three parameters are required to define the two-dimensional unit cell: a, b, and theta. Theta is known as angle of the angle of the unit cell. A, b is a and b are called the sides of the unit cell. So there are the types of 2D unit cell. It means two-dimensional unit cell. Two-dimensional unit cell are five types: square unit cell, rectangular unit cell, hexagonal unit cell, or rhombic unit cell, or parallelogram unit cell. So these are the five types of two-dimensional unit cell. Means two-dimensional unit cell can be arranged in five types. These are the shape or sides, we can say. So these are also called the five Bravais lattice in two dimensional. Same as in three-dimensional unit cell. So we require the six parameter to explain the three-dimensional unit cell. Like this is a cube-like structure we have as a rectangle shape. Cube-like structure is there. So you will see there the three axes are there. One is called this is called the one axis, and second one called this is axis. So we can give the name of this x axis, y axis, and z axis. So these are the axes are there, and each sides a length are there. So we can give the also name of a, b, and a, b, c. We can give the name of this, and angle of alpha, beta, and gamma we can see. We can give the also proper measurement or parameter of the angle of the length of the parameter. So we can give the name of the proper way. Six parameters are required to the define the 3D unit cell. And how many types of 3D unit cell? So cubical unit cell, this is a cubical unit cell. A is equal to b is equal to c, and alpha is equal to b, alpha is equal to beta is equal to gamma is equal to 90 degree. Same as tetragonal unit cell. This is the tetragonal unit cell. So alpha is equal to b not equal to c, and a is equal to b, b not equal to c, and angle we can say alpha is equal to beta is equal to gamma is equal to 90. So this is the second type of tetragonal unit cell of the three-dimensional unit cell. And further we will discuss again third type of known as hexagonal unit cell, and fourth one is called orthombic unit cell, and fifth one is called rhombohedral unit cell, and sixth one is called monoclinic unit cell. Seven one is called triclinic unit cell. So these are the seven types of three-dimensional unit cell. Means three-dimensional unit cell can be arranged in seven types. So in this way we will describe it in details further. Now come to the point next. You will see there in unit cell, according to unit cell, on the basis of parameters. A unit cell, we can define the unit cell, three-dimensional unit cell can be defined on the basis of their parameters. So seven types of unit cell are found according to the parameters. First, again we discuss the cube-like structure. Suppose in this cube you will see there, this is a x-axis, this is the y-axis, this is the z-axis. Student, you will see there, this is a point where, so distance from this point to this point is known as a, small a. Opposite this angle will be alpha. Parameter of the a is called alpha, or angle parameter angle of this parameter is called alpha, and toward this From this point to toward this point, a length of this side will call the b, and angle of this parameter is called beta. And same as from this point to toward this point, this axis in the y-axis, so length of this called the c, and angle of this parameter is called the gamma. So it can be measured by the proper way. So in this way we can say that alpha, beta and gamma are the axial angle, and a comma b comma c is called the axial length. So these are the a lattice, Brevis lattice also known as, these are called also called the Brevis lattice also, or angle of the cube also we can see. Now in this table we will discuss there as the three-dimensional types of three-dimensional unit cell. We can calculate these. How many types of simple body-centered FCC or ECC can be found in the cubic cell or tetragonal? Suppose any crystal is cubic form, so this side will be A is equal to B is equal to C, but alpha is equal to beta is equal to gamma is equal to 90 degree. So all the three types of cube can be seen there, like simple FCC, BCC, means three types of unit cell can be useful to make the cubic, means cube. To form the cube we require the three types of unit cell: simple, BCC and FCC. In tetragonal structure we require an explanation of side A is equal to B not equal to C, and angle will be alpha is equal to beta is equal to gamma is equal to 90 degree. There we require the two type of unit cells, simple and body centered. And to form the orthombic structure, in this side A not equal to B not equal to C, alpha is equal to beta is equal to gamma is equal to 90 degree. Four type of unit cell we require: simple, FCC, BCC, ECC. And in monoclinic, A is not equal to B not equal to C, alpha is equal to gamma is equal to 90 degree, beta not equal to 90 degree. Two type of unit cell we require: simple and ECC. And to form the triclinic structure, A not equal to B not equal to C, alpha not equal to B not equal to gamma not equal to 90 degree. So only require one type of simple structure of unit cell, simple unit cell we require that to form the triclinic. And in the hexagonal structure, in the sides we explain there, A equal to B not equal to C, and gamma alpha equal to beta equal to 90 degree, and gamma is equal to 120 degree. It will be a mixed form unit cell. This is called the hexagonal. To form the hexagonal we require the mixed type of unit cell. And for the rhombohedral, our sides are there: A equal to B equal to C, and angle of alpha is equal to beta is equal to gamma not equal to 90 degree. A very simple structure unit cell we require to form the rhombohedral. So in this way we can say that total 14 types Brevis lattice we require experimentally, and theoretically we require 28 types. Because if we follow the as a theoretically, so three-dimensional structure, to form the three-dimensional structure of unit cell, so there are types of 7, and when in each 7 types of unit cell, when we follow all 4 types of unit cell like simple, ECC, BCC, FCC, so we can form the 28 types of structure. But as experimentally we can form the only 14 types is possible there. So that's why these are called the Brevis lattice cell. Further details we will discuss about that. Thank you. Good day then.